Hi everyone, and welcome to Geometry, Lesson 8.2, Trigonometric Ratios. So the first question is, what are they? So let's take a look at some information. A trigonometric ratio is a ratio of two sides of a right triangle. And notice the triangle must be right, otherwise these ratios don't apply. So the first trigonometric ratio we are going to talk about is the sine function. Okay, and these are functions, they're operations that happen on an angle measure. So the sine of angle A is going to be the opposite sides measure divided by the hypotenuse measure. Okay, so it's all about where angle A is. If angle A is this angle, then I would go to the opposite side and then the hypotenuse. If angle A was up here, we could go opposite this way and then hypotenuse. So it's all about where your angle is. It's like a point of view. So if I'm standing on A, what's opposite from me? Okay. The next trig ratio is cosine of an angle measure, and that's going to equal the ratio of the adjacent side to the hypotenuse. So angle A is here, the adjacent side is the side that touches it, that's not the hypotenuse, and it's divided by the hypotenuse measure. Now remember, the hypotenuse is always across from the right angle. So that's how you can identify the hypotenuse. Then you find the angle, the opposite side is the side that doesn't touch it, and the adjacent side is the side that does. Finally, the last trig ratio is tangent, and tangent is opposite over adjacent. Okay, so the opposite side divided by the adjacent side. And we do have an acronym to help you remember. So it's SOHCAHTOA. I like to say it's what you do when you hurt your toe. You have to soak a toa. But some people call it the famous Native American princess that you've never heard of. So anyway, the acronym helps you remember which ratio goes with which function. So this stands for sine opposite hypotenuse. So this is sine equals opposite over hypotenuse. This stands for cosine adjacent hypotenuse. So this is cosine equals adjacent over hypotenuse. And this stands for tangent opposite adjacent. So that's tangent equals opposite over adjacent. Okay, and I love that acronym. It really helps with remembering what all of these ratios are. Let's look at an example where we actually apply the ratios. In example 1, they ask us to write each trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. So in this triangle, they want us to find the sine of angle R. So remember, you find the angle first, and from here, you have to think about which sides do you need. Okay, the 5 is the adjacent, the 12 is the opposite, and the 13 is the hypotenuse because it's across from the right angle. So see if you can figure out what that ratio should be, and then check your answer. So the sine of angle R is the opposite side over the hypotenuse. So it's 12 divided by 13, which if you do that in a calculator, you'll get 0.92 if you round it to the hundredth place. The next one we need to do is the cosine of R. So again, see if you can write down what that ratio is and then check your answer here. So the cosine of angle R is the adjacent 5 divided by the hypotenuse 13. So you get 5 over 13, and if you divide that in a calculator, you get 0.38. So the cosine of angle R is 5 over 13, which is 0.38. Finally, we need the tangent of angle S. So again, see if you can write your ratio and then check your answer here. So the tangent of angle S is the opposite side over the adjacent side. Now, angle S is here, so opposite from it will be the 5, and adjacent to it will be the 12. So it's 5 over 12, which if you do that in a calculator, you get 0.42. So it's time for you to try it. I have 3 check it out questions for you to work on. In check it out number 1, you have to write each trig ratio as a fraction and as a decimal rounded to the nearest hundredth. So in part A, they want the cosine of angle A in this triangle. In part B, they want the tangent of B, and in C, they want the sine of B. So pause this video and do those questions, and then come back to see what's next. Okay, so in your attendance question, I asked you about special right triangles, and that's because we often use special right triangles when we're dealing with trig functions. So in a 30, 60, 90 triangle, we had side lengths of 1, 2, and the square root of 3. Okay, the 1 side is across from the 30, this is 1x. The 2 side is across from the 90, this is 2x. And across from the 60 is the square root of 3 times x. In a 45, 45, 90 triangle, okay, we had sides of 1 and 2. So across from the 45 degrees, we have 1x's, and across from the 90, we have the square root of 2 times x. And we can use these triangles to create trig ratios. Now, when we're dealing with these, notice we have square roots involved, so we have to make sure to simplify our ratios completely. That means if there's a square root in the denominator of the fraction at the bottom, that means we need to rationalize our square root. So you may want to review how to rationalize a fraction. Let's take a look at an example. Okay, so in example 2, they said to use a special right triangle to write the sine of 60 degrees as a fraction. And notice they didn't actually give you the right triangle. So what you need to do is figure out which triangle to use, the 30, 60, 90 or 45, 45, 90, and see if you can make a ratio for the sine of 60 degrees. You need to reduce out any variables that were in those side lengths and then simplify your fraction as much as possible. So see if you can do that and then check your answer in just a second. So I decided to use the 30, 60, 90 triangle because it has an angle that is 60 degrees. So what I'm going to do is I'm going to pretend I'm standing on the 60-degree angle, and I'm going to say, okay, sine is opposite over hypotenuse. So which side is opposite from me? I'm going to say, oh look, the square root of 3 side is opposite. So I wrote square root of 3 on top. And then I said, which side is the hypotenuse? Well, that's across from the 90. That's the 2 side. So I wrote the 2 side at the bottom. And then I reduced my variables out, and I got the square root of 3 over 2. Now, did you have to write these variables in the first place? No, you didn't. So if you remembered to just write the plain numbers, you can just write the plain numbers. You don't have to worry about reducing. So that's it for this example. You have a check it out question coming up next. In check it out number 2, they asked you to use a special right triangle to write the tangent of 45 degrees as a fraction. So pause this video and see if you can do that. Don't forget to simplify your fraction as much as possible. And then hit play again to see what's next. You can use your calculator to find trig values. So the first thing that you need to do is make sure your calculator is in degree mode, because there are 2 different ways to measure angles, degrees or radians. And this year we're using degrees. So what you need to do is press the mode button, which is right here. Press mode. You're going to hit the down arrow to scroll down to where it says radian right here. And then you're going to use the right arrow to scroll to degree. And then you're just going to press enter so that the degree has this black rectangle around it. Okay? Once that's done, you're going to hit second and mode, and that will quit out of this menu, and it'll take you right back to where you normally are. Now, if you have a newer calculator, it always has this menu across the top, so you can know what mode it's in. Right now, mine is in degree mode. And once you set the mode, you don't have to change it unless somebody else has been using your calculator and they actually changed it to radian. So it should stay in degree from now on. Let's do some examples where you have to use your calculator to find some values. In example 3, they ask you to use your calculator to find each trigonometric ratio and round to the nearest hundredth. So in part A, they wanted you to find the cosine of 76 degrees. So what I did is I took my calculator and I typed cosine 76. And this is a special button on your calculator. It's right above the number keys. You'll see the one that says sin, cos, tan. So you press the cos button and then you type 76. I closed my parentheses, but you don't necessarily need to do that. And then I got this decimal. Now all I have to do is round it to the hundredths place. So the final answer is 0.24. Okay, so you're going to try the next two. See if you can do B, the sine of 8 degrees, and C, the tangent of 82, and then hit play and see if you're right. For the sine of 8 degrees, you would type sine 8, close the parentheses, and you get 0.14 if you round this to the hundredths place. So the answer here is 0.14. For the tangent of 82, you would type the tangent of 82, close parentheses, and you get 7.12. If you aren't getting those answers, please contact me. I want to help you with that because your calculator is probably doing something weird. So let me know what's going on and I will try and help you with it. For now, you have another check it out question. So let's try it again. In check it out number 3, you're using your calculator to find each trig ratio rounded to the nearest hundredth. Letter A was the tangent of 11, B was the sine of 62, and C is the cosine of 30. So please do that on your response page. And that's it for this video. You have another video coming up with some harder applications of the trig functions. So please make sure to watch it.